Hey everybody, Mr. Judson here. So we have one day left of learning something new with derivatives. That doesn't mean we've done every derivative there is. There's some that we don't cover until next semester just because it's not part of Central Washington's program. But that is, what if I have e raised to some exponent? How do I take the derivative of that? Okay, and it's, it's almost as easy as the natural log derivative. The derivative of e to the u is just e to the u times the derivative of that exponent. So e to the u prime. That's it. It's pretty easy. As a matter of fact, it's one of the few things that I know of where when you take the derivative of a function, it doesn't change. I'm talking about this function right here. Y equals e to the x power. If I want the derivative of that, the derivative is e to the u, same thing, times the derivative of the exponent, which is 1, which when you multiply by 1, it doesn't change anything. So e to the x is the derivative of itself. All right? It's the only time I know of where that happens. All right. So let's try a couple examples here. All right, so I've got f of x equals e to the x squared minus 2x, and we want to find the derivative. So to do that, f prime of x is going to equal e to the u, which means the exact same thing, e to the x squared minus 2x times the derivative of its exponent. So the derivative of that exponent would be 2x minus 2. Okay? This is not part of the exponent, right? It's being multiplied times this function. So a lot of times what I'll do is I'll just rewrite this in parentheses 2x minus 2 times e to the x squared minus 2x. That way I'm not worried about, somewhere later on in the problem, maybe I get messy and this looks like it's part of the exponent. I'm not worried about that now. All right? And I have seen that happen. People progress through a problem and this thing, eventually it works its way back up into the exponent, and then they start multiplying those things together. No, not supposed to do that. Right? There's my derivative right there. Right? Let me get you guys one to try. All right, so let's see if we can find the derivative of each of these. You guys give it a shot. All right, so to get the derivative, I just want e to the u, so the exact same thing, times the derivative of the exponent. And the derivative of the exponent is 2, and so I'll just rewrite that as 2e to the 2x minus 1. There's my derivative. For the second one, I got to make sure I realize that we're multiplying two things and there's a variable in each. That's how we know we have to use the product rule. All right, so my derivative here is going to be derivative of the first, which is 2, times the second part, so I'm not doing anything with this, plus leave the first part the way it is, 2x, and then take the derivative of this, which would be e to the u, u prime. When I take the derivative of the exponent, I get 1. So that 1 doesn't really do anything. I think when our book answers these, what they're going to do is they're always going to factor out anything that's common to both terms. All right, so I see a 2 in both terms. I see an e raised to the x minus 1. So if I factor that out, what I'm left with here is 1 plus this x right here. So 1 plus x. And then again, if you wanted to move that in front just so it wasn't confusing, you could do that. You could say 2 times 1 plus x times e to the x minus 1. There's my derivative. Okay. But I don't care which one. Either one of these is fine. And I would get used to factoring these just because it's nice to check your answer in the back of the book and see that you did things right. If you don't factor, you're constantly looking in the back of the book and seeing something different, and then you just, you don't know it. You're left wondering. All right, let's try another one. All right, let's see if we can find the derivative of this. So, you know, when you first look at this, you're probably looking at going, okay, let's see, natural log, that's u prime over u. But that's going to get messy, right? So what we would want to do here is first of all say this is the natural log of 1 plus e to the x minus, because when you divide with exponents, you subtract those exponents. So natural log of 1 minus e to the x. And now I would do the derivative. I'll do u prime over u for each of these. So f prime of x is going to equal u prime over u. So I want this in my denominator. And then I want the derivative of this in the numerator. So derivative of 1 is 0. Derivative of e to the x is just e to the x. And then minus, okay, I got to do u prime over u here. So I'm going to put that in the denominator. And I want the derivative of this in the numerator. So derivative of 1 is 0. Derivative of this will be a negative. And then I've got e to the x, so I'll do e to the u prime, which is going to be 1. So just like over here, the derivative is just e to the x, except it's negative. And since we're subtracting a negative, we can go ahead and just add that. So e to the x over 1 plus e to the x plus e to the x over 1 minus e to the x. So if you check this with the back of the book, you may see this as an answer, or they may get a common denominator and add those together. I don't know. I always like to be prepared for, you know, whatever's coming. If they found a common denominator, then let's see, I'd have to multiply this side, top and bottom, by 1 plus e to the x. Over here, I got to multiply top and bottom by 1 minus e to the x. And so if I do that, my common denominator, if I FOIL this, I get 1 plus e to the x minus e to the x, and then minus e to the 2x. Right? When you multiply things with exponents, you add those exponents together. So x plus x would be 2x. So minus e to the 2x. In the numerator, I would get e to the x minus e to the, add the exponents, I get 2x. And here I'll get plus e to the x, and then plus e to the 2x. So let's see, these two things add up to 0. Those would add up to 2e to the x. And so you might see this. I don't know if you're going to see this or the previous answer. This one right here. But I wouldn't be surprised if you saw that. Okay, so we just want to be aware of it. All right, so that's it. That's what we have for today. Learning how to take derivatives with e to the u. So not a rough day at all. On Thursday, what we're going to do is start dealing with, natural logs of u and e to the u, and how do you find the equation of a tangent line? How do you do implicit differentiation? And that'll be the last thing we learn before we start reviewing for our final exam. All right, let me get you guys an assignment. All right, so we're on week 17 now. This is Wednesday's piece. You guys won't have a Monday piece because we didn't have school. It's Martin Luther King Day. Page 357, we're going to do 35 to 46. We'll do all of those. All right, you guys, that's it. That's all we have for today. So take care, stay safe. I will see you on Thursday. Bye.